Hey everyone. Oops. And
technology.
Oh yeah, the show have started. So I'm Igor. I'm from Minsk, not far from here. Anyone else from Belarus here? No? Okay. Anyway, I'm making the conference more international. Coming from another country, a few words about myself. I'm team lead at analytics department, leading some group of people who are doing data analytics, some data processing things, about 10 years in IT, like an engineer, in lots of roles. My second specialty is quality assurance, and I speak quite a lot of the conferences, but most of them are about quality assurance. So I'm trying to collect links on this website. Unfortunately, lots of them are also in Russian, but I believe some part of the audience also knows Russian quite well. If you are interested, feel free to visit. Let's see why I'm here and what we're going to talk about today. So I want to share my experience and my team experience of the Google Cloud usage. So I'm not from Google, as you see. That's why we're not going to sell you this technology. I just want to share this, and that's why we're here. Also, we will talk about data warehouse as a solution itself. So we will discuss its architecture, why we need data warehouse. And yeah, as I mentioned, I will talk about good and bad things as well. So that's not advertising of Google Cloud. So, and this guy, yellow one, will help me a bit. His name is Kolobok, as you might know. Well, yeah. A few words about Toptal, and this introduction is important to understand why data warehouse is important for us. We're a freelancing platform, and the difference from other platforms is that we are screening freelancers. So that means that if you're part of the platform, you don't need to compete with some cheap developers from India. So only good people are there. Clients are also filtered, so you will not see jobs like create me another Facebook for $100. So all the jobs are actually evaluated for the technical implementability. So if it is possible actually to achieve what clients need, and only after that the job is proposed to the market. And our focus is on automation and on quality. So we try to make our results predictable. That's why our business process is really highly automated, and when you have something again, automated, you can actually improve it, you can improve the quality, you can see bottlenecks, and that's where analytics department is coming into place. What we do, we help business in decision making. We supply business with the data, which can be used as a ground to make some decisions. We're helping to control business process. We're checking that okay, we are delaying with reply to some developer, designer, or with client. It's all raising alarms, and this is what analytics department is doing. And this is why we build in lots of reports, charts, dashboards, KPIs, whatever things related to this data processing world. Why warehouse? Why I'm talking about warehouse and what it is really. In order to say what's really why we need warehouse, I will show you the evolution of our analytics infrastructure, what we started with, and how we evolved and come to warehouse. Initial idea when we have huge Ruby on Rails application, and when there was a need to draw some charts and build some dashboards, okay, let's create another Rails application, attach it to the database with the data, and draw some information, charts, dashboards, whatever. This is quite straightforward solution. It worked up to some scale, and at some moment we saw that really we have lots of data, and that such simple approach doesn't work anymore. We took, which was they took the solution which helped us to scale. It was Spark and Scala as a programming language. And it was something in the middle, so we are loading data with Spark, we handle it, we processing it, and provide the data through some APIs to Ruby on Rails application, and then again, show charts, dashboards, and whatever. So that was quite clear approach and easy to understand. But we faced quite big set of problems with both of them. First of all, there is no execution history. You show some chart yesterday. Today, you open in the same page and see another picture for yesterday because some underlying data has been changed. Someone did something on production database. Lots of things are happening, and you don't have any control. You don't see anything about what happened, and Kolobok is really sad about it. So also, the solution was too monolithic. So it is like single application, okay, two applications. But really, when you have lots of connections, it is really quite hard to debug, and we need to somehow separate these reports, dashboards, and whatever. SQL code, by the nature, is really poorly unusable. You're not able to create functions, methods, classes in SQL, and even if you are using Rails ORM on top of your database, you are reusing classes. But again, all ORM is transformed into the same SQL, and it is again coming to some string concatenations. And this is, well, when you see SQL query for 2 pages, you are just trying to give up and forget about it as a nightmare. And it took too much time for us to create, to satisfy our business demand. So if someone needs to draw a new chart to see some additional breakdown of data, well, he created a ticket for our department. We are creating a new HTML page. We deploy it to production. So, but maybe they might saw the data and say that, okay, that was interesting, but not useful at all. Let's start from the beginning from another chart. So this doesn't work. It didn't work. That's why we found, well, friendly speaking, it is industry standard for such things, but somehow we started from it only on the 3rd level of evolution of our system. Oops. We figure out data warehouse. This is a quote from Wikipedia. Large store of data accumulated within wide range of sources within a company and used to guide management decisions. This is smart words, but when it comes to technically how it's really implemented, we have the following pipeline. We have lots of data sources. It can be databases, it can be some external APIs like Google Analytics, it can be, I don't know, LinkedIn, web page, scraping, whatever. We extract this data, we transform it in the way it is usable, and we load it into the warehouse. Load it to warehouse. Yeah. This warehouse is loaded with data, and then this warehouse can be used in order to explore data, to build reports, to build charts, so you can query warehouse to ad hoc. The data is stored in uniform format, so it doesn't matter for us from which source the data came from. We just have a single API, single way of interact with this in order to do things right. Let's talk a bit more about technologies, how it can be implemented. For this warehouse solution, for this blue part, we chosen Google Cloud and 2 things from Google. One is Google Cloud Storage. Well, this is, you can understand it as a file storage. And Google BigQuery in order to see the data. A bit deeper, what is cloud storage and how we use it? We store there all historical data, every computation which happens, every new chunk of data that we extract, we store it into the Google storage, and even if we maybe will not need it in the future, but who knows? And usually we need it, for example, to reconstruct changes history. We're having daily snapshots for each day, and then someone came into us and asking, okay, let me see how our whatever value varies over time, day after day, and we load all these our files and create new ETL to to store to warehouse. So cloud storage is not only part of the warehouse, but it is also one data source for ETL. And BigQuery is used the following way. It has a snapshot of the current situation. So there we have history, but current state of things is in BigQuery. It plays the role of analytics user interface, front end. It looks weird to say that BigQuery is a front end, but in our case, it is the most close term for this, because it is used by stakeholders as a self-service analytics. So we provided them a tool, we provided them an API, okay, Google provided, but we loaded the data there. And the stakeholders are capable to do researches by themselves. Everyone who is interested in data can go there and query something. I was really surprised when one of our C-levels managers came to us and say, oh, hey man, I need some service account to run my script to fetch data from BigQuery. And I was like, it was like some kind of mind blow for me because, okay, you're a C-level manager, but our company is established by developers, by engineers, and well, on all levels, people are writing code. Oh, tomorrow at the same time, I believe even the same audience, Martin will maybe tell a bit more about BigQuery internals and speak more about this. I am saying more from our user experience. Second part, this blue arrow in the middle, it is about the format, how we communicate between ETL and warehouse. We are using Apache Avro. This is, okay, a few buzzy words. So technically, it is a file format which stores data in compact binary format. If you have lots of data, it is not CSV, which will consume lots of space. It is really well compacted and works quite well. And what is more important in it, in addition to the good storage of data, it is data types. The data is typed. Every Avro file has a schema. And we're writing lots of code in Python, and we're losing type safety. But introducing these types on the data level bring us something which provides equality to our data. If some data do not correspond to our file format, ETL is failing, we see the problem, and there are less bugs on production. And for the left part, for ETL, we're using Luigi. Well, who knows Luigi? Okay, who plays Mario? Okay, Luigi is his brother. Why do you know? Didn't you know it? So, yeah, it is named in the honor of Mario's brother, Luigi, and it is Python module developed by Spotify, and it helps you build complex pipelines of jobs, blah, 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 with some resolution, workflow management visualizations. Well, yeah, again, boring definition, simple way. The main concept of Luigi is tasks, is a task. And tasks have target and requirement. Target is something that should be achieved by running a task. And requirements, as you understand, it is something that should be a prerequisite for task to be run. So if target is absent, task is executed. If target is in place, task will not be executed because no need. And before task is run, all requirements of all dependent tasks is run. So it creates some kind of net between all these things. Simple example. Let's say we have a list of developers and list of countries, and we want to know how many developers are from each country. And we are creating a task that will fetch all developers, all countries, join these data sets, and calculate statistics. So this is requirements, this is the target. This is a screenshot from our production when lots of tasks are interconnected, everything is dependent, nobody knows what's happening, but one single task is really easy to understand what he's doing because you see what's coming in and what's coming out. So I believe no one understands right now in my team what's going on there, but each task is some kind of small microservice, which is really independent from all the rest, and it's really manageable. This way we get rid of this monolithic problem of our previous solutions. Yeah, let's switch to more funny part of my presentation. Let's see how it really looks like. I have, well, example, a working solution which is on GitHub, and you can play around with this. The good thing about it that I calculated the statistics. The size of this solution is 500 lines of code, and 300 of them are from generated. So in order to build a warehouse, you need to write 200 lines of code, and this is amazing. And I will show you right now how it can be done. Let's start from the data types. Let's consider that we have the following records. We have a developer who has identifier, okay, name and country ID. We have countries with ID and country name. And what we want to do is to calculate the statistics, where for each country, which is string, we will have developers count, which is an integer. So quite clear task. Let's see how it can be done. Okay. Let's fill some data. So in order to process data, we need to have some data source. It can be database, it can be some external API, it can be whatever. In our case, let's it be our audience. Let's create some list of countries for our audience. I'm from Belarus. Any other countries are represented here? Oh, yeah, that's interesting, yeah. Anyone else from abroad? No, only local people. Okay, let's add one more country. Ukraine too? Okay, Uganda. And let's put few developers from Ukraine to our list. So we will have one developer, two developers, and they will be from this country. So what is typical? Say some name from Ukraine. Petro. Petro. Yeah, it's Petro, it's English, but Petro, yeah. Okay, anyone else? Vasil. This way, yeah? Okay, so you feel what we should get. We should get one person from Belarus, two from Ukraine, and no one from Uganda. What? We need someone from Uganda here? No. Balinza? Okay, let's add someone from some Balinza from Uganda. Who cares? Let's see our warehouse, how it looks like right now. Oops. I need to exit somehow. So we have BigQuery data set where there is no tables right away. So table in BigQuery is our target that should be completed. And also there is an empty bucket where there are no files at all. And we right now will ask Luigi to extract our countries. So how it works internally. Let's run and then I will explain a bit how it works internally. So we will ask Luigi to run task countries and fill this target. What will happen in the middle? Let's press run and hope that internet will work, Google Cloud will work. And yeah, it works fine. So task was executed. And we will see that, okay, a list of countries is uploaded to BigQuery. So we have our file right now, which stores the current state of things. If we will download it, and I'll try to show that I'm not like hiding something on background. As you feel, I wasn't prepared for Uganda or Balinza, yeah, minus jar. So let's see what we downloaded here, really. I will just print what. Do you see the bottom of the page? Sorry. And I will just print it to JSON to see that actually we stored this data. Yeah, you see 3 countries, Ukraine, Belarus, Uganda. How it works, what we did, there is a base class in order not to have lots of boilerplate. What we do, each main method should return data frame, and we store pandas data frame to the cloud storage. This is what table task is doing. And what is more important, in order to run this main method, you can take other files. So you can take other files from storage, process them, and put another file to storage. So it doesn't even touch local file system. And for this task, the target is the cloud. The file is in Google Cloud Storage, other file. It is one thing. And another thing that we can ask Luigi to run another task, which will, oops, not this, which is named Avra BigQuery task. It will upload Avra file from Google Storage to BigQuery. So you're still following me, yeah? So there is one more task dependent on it. And let's see how it works. Okay, let's run. So as you understand, countries are already generated. Developers are not in the cloud. Statistics is also not in the cloud. And there is no table in BigQuery. While it's running the processing itself, it is some pandas tricks where we merge two things together, grouping by country name, applying some calculations for the number of developers in each group, and yeah, returning the result in data frame. So yeah, as you see this execution summary, we executed 3 tasks. One is to generate developers, one is to generate statistics, and one is to upload data from developers by countries to BigQuery. Let's see. Oops, not here. Just a second. Oh, we should go here. Let's refresh. Okay, you see a few more other files are generated. So we extracted more information to our warehouse. And if we will refresh our data set in the BigQuery, we should see another table. Yeah, this is another table. It has country and developer counts columns. It was uploaded just right away on your eyes. And if you will preview, we see the statistics. Ukraine, Belarus, Uganda, everyone is okay, and we can query this table. There is a SQL-like language. There are lots of problems with this, but again, it is SQL-like and it works quite well. This is how your warehouse looks like. Okay, it is really minimal project, but it works, and feel free to extend it for your whatever needs you have. So let's switch to presentation, back to presentation then. Okay. What's on? Oh. There are some tips and tricks that might help you on your way to build the warehouse for your company. First of all, you need to retry all Google interactions. So like Sheldon is knocking to the door to Penny, and he's doing it 3 times. This is what we do when we are working with the Google Cloud as well. Because it is, of course, really reliable, 99.99999%, but from time to time it returns your internal server error, please try again. So, and you retry and it works well. Every file download, upload, usually it's covered by some retry operations, because on large scale, when you have lots of tasks, it happens quite frequently. If you will not do this, of course, unfortunately, the data will not be there where you want. Also, we built a set of microservices in Google App Engine. So why we need them and what they're doing. Why we need them? To solve lots of tasks, but what's helpful in Google App Engine that it is within the same provider in Google, so that's why it's quick and easy to start. We have seamless integration with BigQuery. You don't need to do any tricks. You are just using the data from there. The one problem that we have with BigQuery when we use it in our microservices is that BigQuery is not like a typical database. It is more like it's used more for analytical things. So every request that you do, it will start from 1 second and more. So it is not something that you can really do some quick real-time applications. So we are usually preloading this data to some Redis, and there we can quickly access the data. Also, examples, what we store as a microservices based on this BigQuery data. A few machine learning services where we classify, ranking, do classification, ranking, whatever modern machine learning things are available in place. And there are certain infrastructure around the warehouse that helps us to provide visibility. For example, when each table was updated, whether there are some problems, some usage statistics. So it is all monitoring dashboards. You're creating dashboards, deploy it, and that's it. You don't need to care so much about all deployment scripts and whatever. Summarizing, I explained you all the story from the very beginning till the final results that we have in place. What lessons we learned from this long story? Not long, but anyway. Oops, not so quick. First of all, we were able to create production-ready, minimal production-ready actually solution in 1 or 2 months. We started our work in April, and in June we shown to our stakeholders, and they were really extremely happy. We shown them as it is a prototype, and the problem was that they started to use it immediately. And there are still lots of places in our code, in our namings, where it is still named as prototype. It works for us for more than a year already, but it's still a prototype. And we can't rename it right now because there are too many usages of it. So it shown really well. It was really easy to integrate it with our Google account infrastructure. We are using Gmail for our mails in Toptal. So that's why when we need to grant any access, we're just put an email to the things, and there is no need to create additional users' passwords. We're just within the same. Of course, there is certain vendor lock around this solution, because if we want to switch, we are really dependent on Google, but it works, it provides value, and for now, we're happy. BigQuery clients are really everywhere. So in any modern language, in any analytical tools like Tableau, Data Studio, there is even JDBC adapter, so you can actually connect it like a regular database from everywhere. You can do all the operations like in regular database, but all the data retrieval is like database. It is scalable. Well, thanks Google, we don't have so much data as they are, but we can use their technologies. It is reliable, so even if something is, so what is good in this solution really? If even something is broken on the left part when we ETL data, the data is still available in the BigQuery. So even if in worst case, if we introduced a bug, something is not completely working, people are using just a bit outdated data. That's the worst case that happens right now with our warehouse. And this is amazing. There are drawbacks. First of all, it is this high latency, which I mentioned. Secondly, I've shown you Avra, and Avra is supported by BigQuery out of the box, but not the latest versions. So in order to upload data properly, with all features like date fields from Avra, whatever, you need to do your own processing. Unfortunately, the latest Avra features are not yet supported from Google. I mentioned there are flakiness in Google infrastructure, and we need to deal with this. And BigQuery permission model is not flexible enough. So you can manage permissions only on dataset level, not on the table level. So you are given permissions to all dataset or to nothing. So you can't say that, okay, guy, you have an access to this particular table. It's not possible right away. Maybe it will be changed in the future. So thank you.